All right, so I'm live with 52 weeks of live coding, ML ops, and covered a lot of different weird topics and kind of bouncing around. One of the things that's on my mind this week is the execution environments themselves. Like, where do I play around with deep learning and machine learning? And I've played around with some of them, and there are a couple different things that are probably coming up on my radar. I would say Snowflake MLOps, I'm going to play around a little bit with, but also Sagemaker Studio Lab. There's a lot of exciting things happening with Sagemaker Studio Lab. And so I thought I would go into a little bit more detail with that particular tool and cover that this session. So I'm going to go ahead and share my screen, and we'll go through here and go to Sagemaker Studio Lab. There we go. Get this going. Okay, so let's make this a little bit bigger. Get this full screen. Perfect. Okay, so Sagemaker Studio Lab, you can see here is an environment that is free, similar to, let's say, Colab. And if we take a look at here, I have it running. So you would just go to studiolab.sagemaker.aws, request an account, and if they let you in, then you get access to this. It's I think something that's going to be more prevalent in education. And notice that I picked GPU because I wanted to try a little bit of GPU work today. I've tried a lot of CPU, but I only get 4 hours. Now, there are some advantages here over Colab in that my progress will be restarted, and I have a little bit more of a real environment to work with. So let's go ahead and click on Open Project. And I think the first thing that comes to mind when I look at a tool like this is basically, what do I do? Right? That's I would say probably the first question I have is I look at an environment and what should I do when I get started? And so I think we should look at maybe getting started DL2. And it says dive into deep learning homepage. So this is an open source interactive book that teaches the ideas and the mathematical theory and code for machine learning. So this is kind of a cool concept, right? Is they have their homegrown tutorial here that you can go through and actually notice there's a link here. So if I wanted to check this out locally into GitHub, if I click this link, it would then go and open it inside of here. So let's actually just go through the dive into deep learning here and say, getting started with DL2, request an account, it's free. So that's what we did. Next step, start an instance. I've started GPU, and then select copy to project. So first time users will recommend clone entire repo. So we've done that. Now you're ready to start with the README in the cloned repo. So there we go, there's a README right there. So DL2 represents our attempt to make deep learning approachable, teaches you the concept, freely available, offers depth, runnable code. So this is pretty cool. I like this. And you can see the different people using it. So let's move on now to the README. Go to that next. Discard. Okay, so we got the README here, and it says the DL2 environment contains required libraries for running on the notebooks. Check whether the kernel exists. And so you would go here, and you would go to DL2 Python kernel. So the kernel would be the execution environment for your Jupyter notebook. So we've done that. Now we've already done GPU. You can switch back and forth, and there's also a full book as well, which is again pretty nice. So prerequisites, students, undergraduate, graduates, researchers can use this. And there's also an appendix on mathematics for deep learning that covers all the stuff. So pretty nice, actually. This is really a cool service. Content is structured here: intro, prelim, linear neural networks, multi-layer perceptions, optimizing algorithms, builder's guide, convolutional neural networks, recurrent neural networks, computational performance, modern neural networks, modern convolutional neural networks, computer vision. So, I mean, I almost am tempted to go through this whole thing step by step and record it. It's possible I'll do that. Let's go through here so we see all the different points. Well, let's start. Let's see how this goes. So first step, intro. So until recently, every computer we interacted with, we have some kind of basic data here. This talks over a lot of the examples of how a model works, training, supervised, all this stuff, regression. So for people that want to learn about that, they can go through that material. This is, I guess, a high-level overview. And if I scroll down here, summary. Okay, so that's the prelim. There's data manipulation, data processing, linear algebra. So this is kind of nice. There's some background here. I would say let's go into image classification data set. So here's a notebook that covers image classification data set, and MNIST is really widely used. It's used by, it was originally created by LeCun, who's at Meta currently. And if we go through here, we run this, we get access to that. Next step, we download the data. This is kind of the classic problem to solve. So it's kind of interesting. So what are we using? We're using Torch. So we're using PyTorch. And so it's going to download the MNIST data set here. Looks pretty fast. And it's going to grab it from AWS. Okay, and now we're going to look at the length of the data. We see that the training data set has 60,000, the test has 10,000. We look at the shape here, and we've got the 28 by 28, 1 by 28 by 28. So the images in the fashion MNIST are t-shirt, trouser, pullovers, dress, coat, sandals, shirt, sneaker bag, and ankle boot. So this is a function here that will just kind of give us a utility to use. And then we can visualize these examples right here. And here are the examples. Let's go ahead and print that out. There we go. So we see these are the things we're going to identify. So what we can do when reading from a training and test set is we can use a built-in data iterator. And this will read a mini batch of data with batch size each time. And this will randomly shuffle the examples. So if we go through here, we get that. Now let's look at the time it takes to read the data. And it took us 1.68 seconds. Now we've got all of our helper functions, we have all this stuff. What we're going to do is make a function that reads the data. So let's go ahead and do that. And then we're going to test the image resizing as well. Okay, now we're ready. We're ready to work with the data set in the sections that follow. Okay, that was pretty good. So there's the data set. And let's do a concise implementation. So we can go through here as well and get in Torch, and then we can load the fashion data set here. We can initialize the model parameters. PyTorch doesn't explicitly reshape the input, so we have to flatten it. And we go to softmax function here, and this goes through the code for that. And we want to keep the conventional softmax function handy. And we want to do optimization algorithm. And then now we want to train. So next we're going to train this, define in section 3.6, how to train a model. So we set the epochs, basically how many times you want it to run. And then we pass in all those values. and it's going to go through here, and it's going to train the model. And we've got that still cooking, and you can see here it's updating. It's got the train loss, the train ACC, and the test ACC. And so on each epoch, the loss is decreased because we're making the model more accurate. There we go. And I am using a GPU. I don't know how fast that would make things. And so that was pretty cool. So that was one fun thing to play with, modern deep learning techniques. What can we play around with that looks kind of fun, that we use our GPUs. So we have a recurrent neural network. That could be kind of cool. Scalability, computational. Wow, training on multiple GPUs. Wow, this is a big book here. Let's look here. Word similarity, analogy, dog breed identification. That looks like a good one. Let's practice dog breed identification on Kaggle. So first up, we go through here, get Torch, we obtain and organize the data set we downloaded. So there's an @save here. So I guess the @save, what does that do? Maybe this will keep it on disk. I don't know what that save does actually. But it's downloading the Kaggle data set, and I might have already downloaded it. I'm not sure actually. And next up, we would organize the data, and then we would tweak it. So the dog breeds is a subset, so it has to be resized and cropped and all kinds of stuff. And then during prediction, the image preprocessing operations don't need to use randomness. And then we want to read the data in. There's a lot of boilerplate code here. And then we want to pull that into there. So now we want to do a pre-trained model, fine-tune a pre-trained model. So the data set is ImageNet data set. So we can use the approach in 13.2, which is find a pre-trained model that was already trained and use it to extract the image features to be fed into a small-scale output network. And then high-level APIs of deep learning provide a wide range of models. We can use a pre-trained ResNet 34. So let's go ahead and do that. And then let's define the training function. So this is a pretty big training function here. It's a lot of code. And we go ahead and run that. And then we can train and validate the model. So at this point, we download a model and we train it on our GPU. So we can see right here that here's the number of epochs, right? So how many iterations, and we see the loss is shrinking, right? So loss is dropping dramatically here as we get more and more iterations. Each epoch is taking a little bit of time to actually run. So I do wonder if there's an easy way to tell the GPUs if they're running, but pretty cool so far. All right. Now we can see that, in fact, the loss, okay, it's still going down, So we can see that the number of epochs can be increased. What do we set the epochs to up here? The number of epochs. I'm not sure where that's set. Maybe that's it. Number of epochs would be 10, maybe. 10 epochs. Did it go to 10? Oh, it did go to 10. Okay. Classifying the testing and set and submitting to Kaggle. So there we go. And it's going to go through and classify the data and submit to Kaggle. So not bad that you can actually do all this stuff directly inside of Sagemaker Studio. What else can we take a look at here? Maybe some natural language inference and fine-tuning BERT. That sounds pretty cool. So this one is a fine-tuning BERT. We have application, sentiment analysis, single text, natural language inference, text pairs, architecture, NLP, and we want to use pre-trained. There's word dev, glove, subword, and BERT. So we're going to go ahead and use this. We're going to load a pre-trained BERT model right here. Next up, we want to do pre-trained model. We want to go ahead and load it, BERT, which is stored on AWS. And then the data set for fine-tuning BERT is right here. We go ahead and rerun this. Download this. And now, once it's downloaded, we would do a fine-tuning of BERTs. So we would say it requires only extra MLP consisting of 2 fully connected layers. So in this case, we go ahead and do this. Run this code. We have number of epochs is 5. And so we're going to retrain it. And so there's just going to be a small tweak to this BERT using the following parameters and cross entropy of loss. And then we go through and pass it all in, and it takes that pre-trained model once it's downloaded. And is it running? I think it's running. I don't see a visualization here though of the training process. I guess I could run it again, but yeah, I don't see it running yet. Maybe the other one is still running. No, that's closed. I think these are all done. Yeah, so I don't know why this one's stuck here, but there's definitely some really good nuggets of things. I mean, there's just a ton of stuff in here to take a look at. So I think it is worth spending some time reading this guide here, the how-to guide. Now there also is SageMaker Studio Lab examples directory called AWS right here. And if we take a look at this, we can see there's computer vision, connect to AWS, custom environments. Now this is pretty cool. If we take a look at this, is that you can see how you could set up different kinds of environments. And so if we wanted to use Julia, for example, how would you do that? Well, let's do this. Let's look at install Julia and see what they tell us. So you would actually open this up in the lab. We would copy it to our project. And you would say, sure, let's clone the whole repo. Now we've cloned that whole repo, the examples. And now, if we go to custom environments, we go to Julia, and we go to install Julia, we should be, in theory, able to run this. Now, I think let's just use the default for now. I don't know how this is going to work, but let's go ahead and run this. So this goes through and it downloads Julia. And then next, we'll install the kernel. So this registers a couple of kernel profiles. So they show up in the lab, which is pretty interesting. I mean, I wish I could see what's happening here, but it looks like it worked. And then we have to register it. And there we go. So with Julia installed, you can create a new Julia notebook from the launcher and follow along. You can also, so it's installed. So if we go through here, we can go through here. Find Julia? I don't see it though. Let's refresh this, and let's just double check that Julia is not here. So I don't see it. I don't see the Julia kernel yet. Well, let's keep this for now, so we can install some packages. Uh-oh. So, yeah, so there must be some way to select. Let's select that kernel. Yeah, I don't know why that's not working. So I'm not an expert on Julia, but it says this will demonstrate is downloaded. Once you've done that, though, Studio Lab Launcher. So File, New Launcher. See, I don't see Julia. I don't. In theory, that should have worked. Ah, there we go. Now I see Julia. Okay. Julia. Interesting. Now, if I go to Launcher again, File, New Launcher, Notebook. That's what I want. Notebook. Here we go. Single-threaded. And there we go. Default Julia. Can I change that? Default Julia. Oh, there we go. I don't know if I need threads or not, but let's select this, and then we go through here, install some packages, and then we do some plotting with Julia. So yeah, I think that this is such a Swiss Army knife type tool, and it looks like AWS is really going to put a lot of attention to it, that it does seem like spending a little time with Sagemaker Studio, especially the fact that you could run multiple environments. I mean, that alone is a win over Colab, right? Colab only does Python. I like it. And I think customization would be a good one to play with as well. So go through here, using data frames. I mean, I like this. This is, I think, cleaner than Pandas. And then if we go through here and we plot this, we can get that working. So let's go ahead and take a look at how this works. So yeah, I don't know. These random kind of hangs here are weird. Like, why is that hanging? Use scaffolding. Like, let's stop it. I'm not sure. I don't know if it's because it's a shared environment that it seems a little sluggish. But what I'm going to do is I'm going to change to multi-threaded. Let's try that. And let's actually go again. Hopefully multi-threaded is faster. I mean, I guess if you're in Jupyter, probably multi-threaded would be faster, but I don't know. So busy, you can see it's busy right here. Okay, and then what does that do? I still see it's busy. I guess we could look here. I wonder if it's got like any kind of a monitoring tool that you can take a look at. Not really. Oh, third-party development. That's interesting. file, new terminal. So what we could do is just do htop apt sudo yum install this time. Oh, well, install. Maybe you can't use yum, I don't know. But we can run pop, and we see that it's just hanging right there. There's a Python that would be nice to kill if possible. I don't know who that is. Maybe that was stuck from my last job. So what I'm going to do is I'm going to kill this PID because I don't like it. So I'm going to say kill -9. Now I'll run top. And I don't know what that was, but that could have been causing the problem. Okay, so now we got Gadfly running, which looks cool. And then we plot this. Does it run? Is it quick? So Julia is now 97% of the CPU. There we go. Cool. Now we can access data from S3. So we'll use the third-party API. We'll look at the open data on AWS and go through here. Nice. Using data frames. So it is a little bit sluggish. I don't know if it's because I have a GPU selected and maybe the CPU on the GPU is slow. But if I go back here and run top, we see like Julia is struggling. Okay, but it got some stuff. And now I guess it's moving on to data frames. Perfect. And now we can do group sizes and then plots. So not bad. So Julia is definitely an interesting language, and it has some really nice succinct. There we go. Some nice succinct code here. So yeah, I think there's a lot of things I could play around with. Maybe I'll play with this for a few weeks on live coding and just make sure I understand the big things you can do with Sagemaker Studio Lab, and let's go ahead and plan on that. So yeah, to kind of wrap things up here, the Sagemaker Studio Lab, there's a lot of stuff to cover, and I know many people working on it, and it does seem like an interesting tool for MLOps because you could use it for free, get things working, and then always take that model and put it somewhere else and push it into production. So next week, I'll continue to cover things on Sagemaker Studio Lab. All right, talk to you next week.